we'll get started. And how's is the homework coming along okay? Sort of? All right. Okay. You have Piazza. I had office hours and I had some visitors during office hours, and then you can ask your questions on Piazza. But okay, let's take a look here. Today we'll talk about GGplot and the grammar of graphics. Before we do that, let's talk about our midterm exam, which we got on Friday, and I know you guys are excited about that. So students are always asking, what's the format of the exam? So this is going to be the format. It's most questions will have some kind of code, and I will ask you, what will our output? Okay, and the code is not going to be elegant, and it will not use best practices, and that's on purpose. Okay, because anyone can understand. If you've got good, nice, clean code, anyone can understand that. Test is going to see if you can understand, what the code is doing, right? Sometimes I do feel like I wonder if I'm making this a little bit too hard or not. And students in the past have complained that it focused too much on the details of our syntax, but that's exactly the point, okay? If you ever were to face a technical interview and you say, like, I know R, chances are, for any position that's worth its salt, they're going to ask you tough questions, okay? They want to be able to separate someone who's a casual programmer who just went through a few tutorials online versus someone who's been coding and knows their stuff, okay? So here's an example question, and this one, this one would test your understanding of functions and environments, all right? And so here is some code. I've got f as a function of y, and here, let me make this just a tiny bit bigger for you guys to see. And we're going to say x, superassignment y plus 0.5, 3 times x. All right. We're going to set x to 4 and y to 5, and so the question is, what will f of x return? Okay, so go ahead. You can try to look at this and think this through and figure out what f of x will return. Don't type it into your computer and find the answer, but see if you can figure this out by hand. All right, you guys have an idea? Don't shout out the answer. If you got an idea of what it will be, let's walk through what we have, right? So here we're saying f of x, okay? And in our global environment, we are saying x is 4. So this is, what is f of 4, right? So we're calling, what is f of 4? So here, our function f is a function of y, so that means we are basically setting y equal to 4 when we run the function, okay? We're not using y as 5, okay? We are using, it's f of 4, so we're plugging in 4 here. And then we go through, and we are going to take that value 4, add 0.5 to it, and we are going to assign this to the value x. So this is going to be 4.5, and this will change the value of what? X in the global environment, in the higher scope. So we'll have 4.5 in the higher scope. When we go through the thing, we will do 3 times, and it's going to search for x. Does x exist inside the function's environment, execution environment? It does not. So the function would then have to search the global environment and say, I found 4.5, so it will return 3 times 4.5, and our answer here, 3 times 4.5 is 13.5, okay? So your answer is 13.5, and then we ask, what is x? What is x going to be? It's going to be 4.5 because it changed right here inside the function with the superassignment, okay? So that would be kind of an example. That's an example question, and you'll have a bunch of these. Not this subject, but other types of stuff where I give you some code that might not be completely clear, and you would be responsible for answering that. Yes.
Do we get like a cheat sheet for
You do not. You do not get a cheat sheet for syntax. Sorry. Okay. Okay. So pretty much everything up through week 4 Friday is going to be fair game. So that's from week 0 Friday to week 4 Friday, and then I've listed off these things are not covered on the will not be tested. Okay. So I won't have any calculations involving infinity or not in numbers or dividing by 0 or weird things like that. I'm not going to have subsetting with out-of-bound indices. It's a thing that's like if you try to subset a list of 4 items with using a 5 or subset using null or something like that. Because sometimes it kicks back errors and sometimes it'll give you logical 0 or something, right? So that is not covered. I will not test you on functions that return other functions. Okay, so it'll just be regular old functions where you put things in and it returns the kind of a a vector or a list object or something like that. Okay, no S4 or R reference class object-oriented systems. There's nothing about date conversions without lubridate. Okay, right? That slide was to illustrate how difficult date conversions were before lubridate, so I'm not going to test you on that. And then the dplyr join functions, the inner join and the left join and that stuff from dplyr will not be tested. Okay, but you can expect pretty much everything else is fair game for the midterm. So it's going to be a short answer form. What else do I need to say about that? I don't know. All right, any questions? Yes?
Will we expect the difficulty to be about the same as the homework, or like?
It's probably going to be tougher, all right? A little bit more nitpickier on weird things. So, yeah, anything that was covered in the homework, I feel like is fair to test. Yeah, question.
Could you please elaborate on the first slide where you see calculation involving?
Calculations involving infinity, not a number, or dividing by 0?
Do you mean just like mathematically?
So if you asked R, what is infinity plus infinity, it will return infinity. And if you ask what is infinity minus infinity, it will return not a number. And if you ask, what is 10 divided by 0, it'll return infinity. And if you ask 0 divided by 0, it'll say not a number. There's like weird rules that I don't expect you guys to have all memorized for every possible combination of those things. Okay, so I don't know. Was that your question?
Yeah, like it may show up like in a vector, but it wouldn't be like a map.
Yeah. So that's not covered. Yeah, so you don't worry. There's like a slide from week 1 Monday where I put some of these examples on there. You can skip that slide. Okay. Basically, these slides that I put here, you can skip. Okay. But yeah, you should look through everything else. Okay. Other questions? Good. Okay. So just bring a pen or pencil, probably a pencil and eraser in case you need to fix something, and then we'll write what we have. 45 minutes is the length of the exam. Okay. Yes.
Sorry, is it gonna be mostly just like writing answers, or is there gonna be like short answer codes? I'm just curious.
Mostly, I will present the code and you write the output. It just makes, if I ask you to write code, oftentimes it takes a lot longer to grade. Because a lot of times there's multiple ways to do the same thing. And then, and then I have to say, is this going to work if you subset it in this very strange way that might be correct? But, so anyway, yeah. And then for some of the questions, it will be kind of like all or nothing, and other questions, there could be partial credit. So for example, if I have a function or a loop where the output, part of the output says cat this or that versus print this or that, there's a difference, right? So if I say cat eye or something, it's going to put all the numbers on the same line unless you put in a /n separator. But if you say print, then it will print the object. It will put everything on its own line along with kind of square bracket 1 type of thing. And so, if your output, puts it all on the same line when it's supposed to be on separate lines, then you'll probably lose like 1 point or something. But you'll get partial credit for that if you have demonstrated that you understand the other aspects of the code. Okay. If the code, like, I might purposely write some bad code that will crash, and you'll need to say this code will not run. It will produce an error. You don't need the exact wording of the error. You don't need to say the error is going to say, I don't know, something. But you do need to say that it will return an error. Okay. Is that good? All right, let's talk GGplot, GGplot 2. So with GGplot, the GG stands for Grammar of Graphics. Grammar of Graphics was a system of kind of data visualization that Leland Wilkinson created, and it's kind of this very formal, structured perspective of what a data graphic is supposed to do. Okay, and so he establishes this grammar of graphics. Hadley Wickham then took those kind of rules and created the package GGplot that implements these things into R. Okay, it's not the ultimate package for graphics, and it's not intended to be the only way to produce graphics. However, I think it is very good, and it makes very good looking plots, and it allows you to customize and make things, I think, nicer and better. Sometimes base graphics in R will be the fastest way, okay? And that's because a lot of times when you have a package, or you load a package, or you create some kind of object, it will often have its own plot method. Right? So it'll have, like when you create a linear model object and you call plot on that model fit, it creates its own set of graphs, right? It creates its residual plot and the QQ norm and the leverage plots and all of that. And that's great, right? Plot makes that aspect very quick and easy, and you don't have to generate your own plots using GGplot using that. So sometimes plot is very useful, or many times plot is very useful in of itself. Okay, in data graphic, what we are doing is we are mapping properties of the data to visual properties of the graphic. All right, so if you think of your table of data, you've got different columns to represent properties of each data, right? Different variables. So you've got categorical variables, you got numeric variables. And when we are creating a plot, what we are doing is we are finding a way to represent that column of numeric data or that column of categorical data in a visual aspect, right? So if you have numeric data, oftentimes we will map that value to a position on the x-axis or a position on the y-axis, right? And that's how we make a scatter plot, and that makes a lot of sense. But if we wanted to, we could also take that same variable and map it to a different aesthetic attribute, such as the color of the point or the size of the point or something like that. We are just mapping aspects of the data to a visual property. And it feels a little bit different because you're talking about making a scatter plot, which I think is very intuitive, but and you're talking about making some other kind of plot where we are mapping numeric values to scales, the size of a point. But at an abstract level, they are the same. It's the idea of taking a variable, a property of the data, and mapping it to a some visual property. Okay. Let's see. And so to kind of illustrate how the grammar graphics compares to R's base graphics, we'll take a look at this data table. All right. So here, this is a summary two-way table, which means that we've got two categorical variables. We got variable A and variable B. Variable A has three categories, A1, A2, A3. Variable B has two categories, B1 and B2. And we have created a summary table, a two-way table, which kind of shows you, you had 10 observations that were of A1 and B1. Okay. So if we wanted to make a bar plot with the base graphics, the way we would do this is we would say bar plot, and we would give it our two-way table, and we would use the command beside equals true to kind of put the bars next to each other rather than on top of each other. All right, and this is what it looks like. Right, we got A1, A2, A3, and then we've got kind of the heights of the bars here. If we wanted to change this so that it's not going across this way by variable A but variable B, we would have to actually change the structure of our data. It's not too hard, but we have to transpose it so that variable B establishes the columns and variable A now establishes the rows. We throw that into bar plot using the same command as before. Bar plot of the transpose of the simple dat, and we get our resulting plot this way. Okay, and so this figures it out this way. Let's say instead of plotting bar plots or bar charts, we wanted to plot lines. Okay, here we would do something entirely different. We would not call bar plot, but we would call plot. And we would have to, call plot on the first variable, and R would draw a line there, and then we would call plot on the second variable with the lines, okay, and lines will add another line to the plot. What we will see is that the resulting plot, the blue line goes underneath the bottom of the x-axis here, and the reason for this is that when we first initially called plot, it established the y scale from 7 to 12 because it looks at the data and says, okay, the smallest value I have is 7, the biggest value I have is 12. Then when we add a line for the second row, that data goes down to 6. And so when it tries to plot the same data on the same scale, and so the 6 ends up going down here, and we lose it. Okay. Another thing is that the index is being used on the horizontal axis, and it says 1, 2, 3, but it also kind of throws in 1.5, which implies that the index could be a numeric variable, but it's not. It's a categorical variable. We got 3 categories: category 1, 2, and 3 for A. If we wanted to do create graphs like this with GGplot, we have to transform our data into tidy data. Okay, tidy data means each column is one variable, and in each row is a value, right, an observation. And so instead of having a 3x2 or a 2x3 summary table, we would need to have a table with 6 rows, one for each value that we're plotting, and then we would have a column for the variable A and a column for the variable B. So a lot of times you might end up producing something and you get a summary table out, and then you want to use GGplot. You got to convert that table, that summary table, into tidy data. So you got to use either spread or something like that, or gather to achieve what it is that you want to achieve. Okay, so you need to have one variable per column, one row per value. Okay, so this is the same data, just now in long form, long tidy form. Okay. And now what we're going to do is we're going to tell GGplot that we want to create a bar chart where we are going to map each of these variables to a different attribute here. Okay, so we're going to say we want to map the variable a value, which takes on either a1, a2, or a3. We're going to map that to the x position. Okay, and basically that just says along the graph horizontally, over here we'll put a1, in the middle we'll put a2, and over here we'll put a3 or something like that. Okay, to take care of the b column, okay, we're going to say let's change the color of our bar, the fill color. We're going to map that to the b value. Okay, so b value gets mapped to the fill so that the color that gets used to fill in the bars, that will depend on the value in the b value column. Okay. Finally, we want the height of the bar to match this column value. So we're going to say y is equal to value. So the height of the bar, which is established by the y variable, is mapped to the value variable value, and then we tell it to draw bars with geom bar, geometry bar. Okay, and when we do that, and this is what it looks like. Okay, so we load up library GGplot2. We're going to take GGplot of our data in long form. This is the aesthetic mappings. We're going to say the a value column gets mapped to x, the value column gets mapped to y, the b value column gets mapped to the fill attribute. And then we say we want to draw bars. Now we have a few things here. Position dodge tells GGplot we want the bars next to each other instead of stacked on top of each other. And then the stat equals identity. This feels a little bit weird. Generally, geom bar is expecting kind of a table of raw data, and it will tally up the counts for us. It will say like how many observations of category 1 do we have, and it counts through and it says, oh, I've got 10 values with category 1, or 10 observations with category 1. I've got 17 observations with category 2, and geom bar would then put category 1 at 10 and category 2 at 17. However, because we are not telling it to look through and count how many of each thing we have, we're saying just plot a bar at the height of 10 or plot a bar at the height of 9. We have to use stat equals identity. Okay, a lot of these things, when you're first using ggplot, you're not going to remember. How did I do this? Stat equals identity, position equals dodge. You're not going to remember all of this in the beginning, okay? So don't worry about it. There are lots of good references, okay? So first of all, we've got the GGplot2 official page. So just search GGplot2. You click that and go to the documentation, right? docs.ggplot2.org, and this is what we have, okay? So this is a reference, and especially for ggplot2, I think probably the best way to learn it is by saying, I want to kind of create a picture that looks something like this, and you would look at one of the things, so geom_bar, you click that, and you will see it lists out all of the arguments that it has, but most importantly, it provides examples, okay? And you can look at the examples that they have, and you can say, oh, you know what? I want to make a plot that looks like this, and you can see the attributes that they are using here. Okay, so that's the ggplot2 reference. Another great resource is on Safari Books Online. So you go to proquest.safaribooksonline, and you're going to look for the R Graphics Cookbook, okay? And it's already 5 years old now, December 2012, but this mostly uses ggplot. It's very good. The R Graphics Cookbook, and you can kind of create any kind of these things, right? So you want to make bar graphs, make a bar graph with counts or something, and so there's some good examples here as well. Okay, everybody should be taking advantage of Safari Books Online if you're not doing so already. Okay, while you're here at UCLA, the entire O'Reilly catalog of books is available to you, and it's a great resource to just kind of learn things, right? So I know a lot of people want to learn Python, and you can learn Python using those books. I will be teaching a Python course in the spring. I'm excited about that. So I imagine it will fill up quickly. So we'll see what happens. Okay. All right. So that's this is what we've done. GGplot, simple data, long. We've mapped each of these values to these different aesthetic attributes. All right, what if we want to switch things up so that the B's go along the x-axis and the A's, they determine the grouping here, okay? To do this, we're going to use pretty much the same command that we have here, except now we're going to say, we're going to map the B value to the X aesthetic, and we're going to map the A value to the fill aesthetic. That's going to be the only change that we do. We don't have to change anything to the data. So here we say the same command. If you compare these two commands, the only thing here that has changed is that the variable that gets mapped to X and the variable that gets mapped to fill, those things have changed. When we swap those two things, that changes the way our graph looks. GGplot automatically figures out, you know what, I've got 3 different A values, and therefore I need to have 3 different colors for fill, okay? And it says I only have 2 values for B, and therefore I'm going to put one over here and the other over here, and it figures out the mappings that way for us. If instead of bar plots we wanted to make a line graph, okay, here it's also easy to establish. We can say, you know what, we want the X to be mapped to the A value, okay, so our 3 A values get mapped to the x-axis. The value gets mapped to the y, okay. The color of the line will be established by the B value, and we want to group the points, the 3 points together by the B value so that the lines connect, those 3 lines, right? Otherwise, it wouldn't quite know how to connect the lines. So we say the grouping is B value, and then we say draw a line. So here was just changing the way we mapped the variables and saying we want to use the line geometry instead, okay? And we see that the entire graph fits without having to rescale anything. And then it also produces a legend for us, right? I don't know if you guys have ever tried to add a legend to a plot in base graphics. It's not too much fun, right? It's like, it's very tedious, it's a lot of work. GGplot makes legends for us automatically most of the time, okay? So that's very nice. And if you wanted to, you can customize the legend and you can add in all of those tedious details that you might want to. But again, adding a legend is automatic with GGplot. Okay. So yeah, all we have to do, instead of completely changing the way we call the plot, all we have to do is change the geometry from bars to lines, and then and all of those quirks that we had in base graphics, those are gone. Okay, let's talk some terminology for GGplot. So of course we have the data. That's the data that we're going to try to make a visualization for. The geomes are the geometric objects that we draw to represent the data. All right, so oftentimes we'll draw bars, oftentimes we'll draw lines or points. Okay, these are the geometric objects. The aesthetic attributes are properties of the geometric object. So if we're going to plot a point, that point has different aesthetic attributes. Perhaps the most important ones, well, I don't know, this is debatable, is where it is on the x-axis and where it's positioned on the y-axis. But that is an aesthetic attribute, okay? Also, that point can have different coloring. The point can have different size. The point can have different shapes to represent some other aspect of the data, okay? You could even, there's other aspects such as, you know, the transparency level. Is it completely opaque or is it transparent? Obviously, you don't want it too transparent, otherwise you won't see the point. And that's probably not the best thing to use, just because if you, I don't think our eyes are very good at distinguishing transparency levels of different objects, right? So that's what we have, okay? But they're just, the aesthetics are just visual properties of the geometries. And then we map each variable to an aesthetic, okay? The same variable can be mapped to multiple aesthetics, but we need to, you know, each aesthetic thing needs to be mapped to some kind of variable. And the scales are how the values in our data correspond to attributes, the scale of attributes in our of the aesthetic mapping. So, for example, you might say, I want to alter the shading, the color of the bar that I'm representing. And it might be a numeric variable, right? So if your numbers range from 0 to 10, you might say 0 is going to be white, 10 is going to be black, and everything else is going to be some shade of gray in between, okay? On the other hand, if your variables go from minus 1,000 to plus 1,000, okay, then you need to create a scale that says maybe 0 is, I don't know, 0 might be white, plus 1,000 is blue, okay, and the positive numbers are different shades of blue, and then 0 is white, and negative 1,000 is red, and everything that's negative is some other shade of red or something like that, and that would be some way to establish going from the numeric scale in the data to the color scale that we are using for our graphics. Okay. Or if it's categorical, you might say category 1 will be represented by square points, category 2 will be represented by triangular points, category 3 is represented by circular points, or something like that. Okay. Okay, so that goes from our data to our graphic, right? And then finally we have guides. Guides are a way to go from the graphic back to the data, right? When you, the graphics creator, are mapping attributes of the data to the graphic. What needs to happen then, the point of creating the graphic is so that someone can look at the data and basically look at the graphic and in their brain recreate the data in their head by looking at the graphic, okay? So they need to be able to map from the graphic back to the data, right? Otherwise, we would just say, otherwise the point of having the graphic does nothing. If we can't go from the graphic back to the data in our head, there's no point in having the graphic. We would just say, here's the data, look at the raw data itself, right? But a lot of times when we go from a data to a graphic, we reveal patterns, we can see lines or things show up in a cloud of points, and then our brains look at that, and then we can map back to a data and get some kind of understanding. We can say, oh, I see some kind of linear correlation between the data or something like that. But that needs to happen. We need to have some kind of way to map the graphic properties back to the data. And so that happens with guides. Guides are things like tick marks or legends or just something to let the viewer understand the structure of the data from the graphic, right? And a lot of times, you know, different newspapers or whatever might make kind of egregious violations of this by trying to make their graphic too cute or something, putting in, I don't know, horses and boats or something in their visualization, but that makes it difficult to map back to the original data. All right, so here's a typical graphing scenario. You've got some kind of data, all right? Then we're going to take some geometric objects to represent each observation. We're going to have an aesthetic value, and then and we have a scale that defines the mapping from the data to the aesthetic space, right? And again, the aesthetics can be anything, and that's what we have, right? As far as the data types go, the different type of data will determine the kind of mapping that is possible, right? So if we have a categorical variable, we can map that to something like the shape of the point. But you can't use the shape of a point to represent a numeric attribute of the data. Okay, the size of the point is something that probably should be mapped only to numeric variables. Okay, we're mapping the size of a point to a categorical variable does not make sense. Okay, unless it's an ordinal variable, right? You guys know the difference. Like ordinal would be something like small, medium, large. That's technically they're categories, but they have intrinsic, like implicit numeric values associated with them, right? Small, medium, large. That makes sense. But if it's something like the color of the car, don't map that to the size of your point. That doesn't make sense. Color you would map to color. Okay, and then so anyway, you've got different things. So the type of data you have will determine what kind of mapping you do. And then as far as what ggplot requires, it basically requires your data to be in tidy form. Each variable that you might want to map to something needs to be in its own column. You can't, if you got different types of variables or the variables spread across columns, you're going to have to gather that into one column. So you need everything in tidy form, and then you can do the mapping. All right, let's create a graph from scratch here. So here we'll create a data frame, and we've got the x variable, the y variable, and the group variable. All right, so we've got two numeric variables, a categorical variable, and we can create a plot. Okay, so you know, with two numeric variables, it probably makes sense to create a scatter plot, which means the geometry that we use to represent our data will be points. So first we create a blank plot without any geometries added to it, and we say ggplot of our data frame, dat, with the aesthetic mappings, we're going to map the x variable or x value to the x attribute, aesthetic attribute, and the y value to the y aesthetic attribute. Okay, and that's what we have. Right now, we haven't specified any kind of geometries to be used, and so we'll add geometry point to say we want to draw points to represent our data. So we say ggplot, it's the same thing as before, and we say add points to represent the data that we have, and our 4 data points get plotted up on the screen. If we wanted to map that, let's say that attribute group or the variable group, that's a categorical attribute, so it makes sense that we can map it to something like the color of our data point. Okay, so we can say map the color of our point to group. Okay, in the future, we can call ggplot, and that will create an empty plot, and we can add the point geometries. A shortcut to that is to create our empty ggplot to p, and we would add the geometry here. So this is equivalent to saying p plus the geometry. This is the same as what we have here. P represents this blank ggplot. Add the point geometry. And now with the point geometry, we'll map the group variable to the color of our point that's being drawn. Okay, and when we do that, it creates red points and green points, and you know, it goes A, B, A, B for our grouping variables. So there you go. You can also create settings in ggplot. Okay, a setting is not a mapping. A setting is just an aspect that you are establishing here. Okay, so over here we said we are doing an aesthetic mapping. We put color equals to group inside the function AES. This establishes a mapping to an aesthetic attribute. Here we do not have AES because we are just setting the color equal to blue. Okay? And what this will do is it just creates the plots the points in blue. We have no legend because the color of the point here no longer tells us anything about the data. All the points are blue. This does not tell us what group variable it's in or anything like that. There's no, we are not able to map back from the color to anything back in the data, so there's no AES there. This is just a setting. Okay, not an aesthetic mapping, but an aesthetic setting. You can also modify scales, all right? All of these things, again, you're gonna forget exactly what the command is, so always just look at the GGplot documentation and you can come down to scales and kind of see the different attributes that you can change. And so here we can say, you know what, I want to change the scale, the limits of my X scale to 0 to 8. Okay, so we got, this is our original data. The scale goes from 1 to 4. I can change it to say the scale goes from 0 to 8. Okay, it's the exact same data, but suddenly the character of the data feels a little bit different, right? When you change the scale on the data, suddenly the graph feels different. And this is just something you have to be aware of, right? You always want your data, or I'm sorry, your visualization to communicate something to the reader and make it very clear what they're looking at, okay? And so perhaps you want to highlight differences between 1 and 4, and so you have that span the entire space. Or maybe the X value can actually take values from 0 to 8, and you want to establish that we're only looking at a segment of that, okay? So maybe, you know, it all depends, and the story that you tell with the data will depend on these choices that you make, okay? And just like anything, with power comes responsibility, and so you don't want to be purposely misleading with your graphics. There's other things we can modify. The color scale that we are using in our color attribute, okay? And so here again, we can set the color to orange and green. It's written by Hadley Wickham, who's from New Zealand, so he uses U in the word color there. And there we go, we got orange and green. Although on your screen, maybe it's hard to tell, but there we have those points, okay? This is something to note here, is that in base graphics, when you call the plot function, it outputs to the screen. It creates a plot on the screen. Or you might say something like dev.pdf, and that will have the plots output to PDF files, something like that. With GGplot, what it does is it creates a plot object, but it doesn't actually draw the plot object until you request it, request R to print the plot object, okay? And we haven't explicitly called print on any of these functions, but that's because R's default behavior is when you give it the name of a function, it's going to print out whatever that object is, right? The name of an object, R is going to print it out, right? So you say like x plus 5, it's going to take x, let's say it was 10, and add those two together, gets 15, and it returns 15 and it prints 15 out on the screen with bracket 1, 15. When we've been calling GGplot so far, it takes the results of this and it prints it out, okay? However, when you run a script, R might not necessarily print all of those results. And so you need to explicitly call print of your plot object. So you might create a plot object somewhere in your script, and if you want it to be plotted, then you need to call print on it. Sometimes when you are making a graph, you have to keep in mind that the data you're looking at is transformed or summarized before creating a graph. So most notably, we have, when you create a histogram, you don't ever plot a histogram directly from your raw data, right? You initially take your raw data, and then somewhere along the way, you have to create a frequency table that bins the data and says, you've got 15 observations between 0 and 10, 20 observations from 11 to 20, and something like that. So you are creating a summary table, and then you are plotting the results of that summary table, okay? Sometimes you have to keep that in mind, and when you're trying to plot something, you have to create that intermediary table. A lot of times, GGplot has functions that do this for you, okay? So it has geometry histogram, which will create that intermediate summary table and plot that accordingly, okay? And probably most of your functions that, or graphs that you're trying to create, if they're routine things that other people have created, it will probably exist, okay? But that is something you need to keep in mind, that you can't just, you might not necessarily be able to make the graph you need unless you create a table that summarizes the data as it needs to be done. Okay, I think we're gonna run out of time here, but and so I'll cover this probably on Wednesday. We'll look at some of the basic geometries in GGplot, such as the point geometry, line geometry, and bar geometry. And so we'll end here for today, and on Wednesday we'll pick up and look at some examples of these GGplot geometries. All right, we'll see you guys in a couple days. Good luck as you finish your homework, and good luck as you study for your exam.